So dear student, I Rakesh Jain from Ganware University. Today I am going to teach you about how to design the stable multivibrator. What kind of circuit we should choose to design a stable multivibrator in laboratory on a breadboard. Basically, multivibrator is a type of circuit, is an electronic circuit which is used to design, which is used to create two-state devices such as flip-flops, relaxation oscillators, timers. Basically, there are three kind of multivibrators: astable multivibrator, monostable multivibrator, and bistable multivibrator. Astable multivibrator is also known as free-running multivibrator. This is a kind of multivibrator in which no state is stable. It continuously switches from one state to another state, so no state is stable because it move. No external trigger pulse is required for switching operations. That's why it is also known as free-running multivibrator. The second multivibrator is monostable multivibrator. As the name implies, mono means one. Only one state is stable. A kind of multivibrator in which only one state is stable. The other state is quasi-stable state. To switch from one state to another state, it requires one external trigger pulse is required. The another name of a monostable multivibrator is one-shot multivibrator. The third one is bistable multivibrator. As the name implies, it is bi means two. A type of multivibrator in which two states are stable, that is known as bistable multivibrator, which is also known as flip-flops. So multivibrator can be used in different kind of applications like to design the timers, to design the relaxation oscillators, to design a square wave generator, rectangular wave generator. We require a stable multivibrator because a stable multivibrator give you the square waves at the output. Now, first of all, the designing of the stable multivibrator. Remember one thing, that in case of a stable multivibrator, which is also known as free-running multivibrator, I'm going to write down this terminology here. Here. So a stable multivibrator, that is also known as free-running multivibrator, in which no state is stable. In this multivibrator, no state is stable. So, right? Generally, it will generate the square wave. Okay. Now, first of all, the transistorized circuit, and the second one is uh, the 555 timer IC circuit. So we can say the stable multivibrator and for this kind of operation. First of all, the pulse width, the time period, the turn on time and turn off time for the stable multivibrator is basically 0.693 R1 plus 2 R2 multiplied by C, or RA plus 2 RB into multiplied by C. You will see the meaning of R1, R2 and C with the help of structure. So first of all, I am showing you the 555 timer IC circuit using 555 timer IC circuit, the STM multivibrator circuit using 555 IC, which is a timer IC basically. Okay. Basically, a 555 IC can be made to work as an stable multivibrator with the addition of three external components: two resistors, which is we denoted by R1 and R2, and third one is the capacitor, that is C. So first of all, just see the 555 timer IC circuit for a stable multivibrator. So let's suppose this is my 555 IC, which I am going to use as a stable multivibrator. So A and B, that is abbreviated for stable multivibrator. And B, this is a 555 IC. Okay, this is a 555 IC. So basically, the fourth number, there are so many number of pins are there. The fourth, it is a 8-pin IC. Fourth number pin, eighth number pin, number pin, first number pin, seventh number pin, sixth number pin, These are the number of pins for the triple five timer IC. 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay. So first of all, whenever you want to design a stable multivibrator, remember the fourth number and eighth number pin, which is a reset pin, and the VCC pin. Basically, 5 volt to 15 volt power supply is required for the power triple five timer IC. So fourth number and eighth number pins are shorted with each other, and connect with the power supply. So the fourth number pin and eighth number pin are short with each other, and they are connected with the power supply of 5 volt to 15 volt. And the sixth number and pin and second number pin, the trigger and six number pin both are shorted with each other because there is no trigger pulse. That's why two number pin is of no use, because two number pin of triple five timer IC of trigger pin, that's why it is of no use, so it will be shorted with six number pin. Then the three external components R1, R2, and C are connected such that in between seventh number pin and fourth number pin, which is shorted with eighth number pin, uh, R1 register is connected. So in between fourth number pin and seventh number pin, the R1 register is connected. In between seventh number pin and sixth number pin, R2 register is connected because 6 is shorted with 2. That's why we can say in between 6 and 2 shorted register R2 is connected. And in between ground and pin number 2, that is shorted with 6 number pin, the capacitor C is connected. The capacitor C is connected. And one number pin is ground. In between fifth number pin and one number pin, a small capacitor, a disc capacitor, ceramic disc capacitor, we can use of 0.1 microfarad or 0.01 microfarad, anyone. So a small capacitor C1 is connected. And from the third number pin, we will taken out the output. And that will be a square. Means on, off, on, off. Now this is the circuit diagram for the stable multivibrator using triple five timer IC. And the time period, the total time period for the pulse width is given as 0.693 R1 plus 2 R2 into C. 0.693 R1 plus 2 R2. Now we want to design this, we want to use this on breadboard and see that whether it will generate the square wave, or if we connect a LED, then whether it will give you the perfect square wave or not. So the designing is not because the turn on time is 0.693 R1 plus R2 to C, and the turn off time is 0.693 R2C. So the total time is total time period, total pulse width or total time period is given as turn on plus turn off time, that is 0.693 R1 plus 2 R2 into C. So what is the frequency? Frequency is equal to 1 upon time period. So with the reciprocal of this, we will find out the frequency. So what is the frequency? Frequency is equal to 1 divided by time period. So when we will put this value of time period T with the division of, then we will find out 0.693 R1 plus 2 R2. So as a result, we will find out this 1 upon 0.693 will be 1.4. 1.43, or we can say 1.42 divided by R1 plus 2 R2 into C. Okay, so this is the formula for the frequency of this. Now we want to perform this one on a breadboard so that we will find out the perfect result as a square wave, or as a, if LED is connected, then as a to glow the LED. So how the different kind of values will be chosen. So as we know the frequency formula, remember one thing, that uh, the R1 and R2 should be in the range of 1 kilo ohm to 1 mega ohm. First we choose the capacitor C1. First we choose the capacitor C1. Just you see, you are able to see this capacitor C1, okay, of minor value, like for 0.1 microfarad or for 0.01 microfarad. Okay, so we will see that how we can find out these values. Wait for it. Remember, the R1 is about a tenth of R1. R1. The R1 should be about a tenth of R2. Okay, whatever the value of R2, we just choose R1 as divided by 10. Okay, for a perfect result, how we can say, remember these rules, that R2, sorry, R1 should be chosen the 10th value of R2 for a perfect result. So R1 should be chosen as R2 divided by 10. For example, R2 is 10 kilo ohm, then what should be the value of R1? The R1 should be of 1 kilo ohm. The R1 should be of 1 kilo ohm. Okay, divided by 10. Now let's suppose we want to find out, let's suppose we want to design this circuitry at 6.8 kilohertz. Let's suppose we want to design this circuitry at 6.8 kilohertz. 6.8 kilohertz. Then how can we choose this value? Let the frequencies, at any frequency we choose, let this the frequency is 6.8 kilohertz. Any frequency you should choose. 1 kilohertz, 10 kilohertz, any. Let's the frequency is 6.8 kilohertz. Now we want to design the stable multivibrator so that a perfect square will be, we will find out at the output. So how can we design? Because the frequency is 6.8 kilohertz. First of all, choose the value of C1, the capacitor C, this one. The capacitor C1 should be choose as 0.1 microfarad or 0.01 microfarad, any one. Okay. Why we should choose the capacitor C1 value first? Because R2 is equal to 0.7, because that is a formula that this frequency is equal to 0.7 divided by R2C. I just write down. The time period is 0.693 R1 plus 2 R2 into C, or frequency is equal to 1.44 upon R1 plus 2 R2 into C. Okay. But this frequency is also related with the capacitor C1. How? That is 0.7. These formula we should always see during the time of designing, while we want to design the perfect oscillator. So 0.7 divided by R2C1. R2C1. These boxes of green color are we use during the time of designing. That R1 should be of approximately R2 divided by 10. No, frequency we can choose anyone, but the frequency should be equal to 0.7 divided by R2C. Now, first of all, choose any value of C, capacitor C. So let's suppose the capacitor C1 is 0.01 microfarad. Either we will use 0.01 microfarad or 0.1 microfarad or 0.001 microfarad. A type of capacitor on which 104 is written, it means it is 0.1 microfarad. A capacitor on which 103 is written, it means it is 0.01 microfarad, like this one. Okay. So let the capacitor we choose as 0.01 microfarad. Micro means 10 to power minus 6. Okay. Now what should be the value of R2? What should be the value of R1? So we know that F is equal to 0.7 divided by R2C1. So what is R2? So R2 will be equal to 0.7 divided by F. So F is what? 6.8 kilohertz. 6.8 kilohertz means 6.8 multiplied by 10 to power 3 plus 3, that is kilohertz, plus 3, that is kilohertz, multiplied by C. C1 is what? 0.01. 0.01 multiply by I just do. Okay, multiply by microfarad is there. This is 0.01 microfarad, so multiply by 10 to power minus 6 is also there. Now what is this? So what should be the value of R2? So R2 is equal to 10 to power plus 3 and 10 to power minus 6. So it will be 10 to power minus 3. So 0.7 is at top side, multiply by 10 to power plus 3, because 10 to power minus 3 when will move to the outside upside, it will be 10 to power plus 3. And also 0.01 is there. So when we will remove this point, then 2 0 are also present at the top side. 2 0 are also present. Also 6.8 is there. So when we will move this point, one more 0 will be transferred to the upside. Now it will be. And from the top side, when this 0.7 is there, so when I move the point, then 10 will be at the lower side. Now the remaining are 68 only, because 10 to power plus 3 and 10 to power minus 6 we have already been solved as 10 to power minus 3, that will move at the upside. So 3 0 will be there. 2 0 comes from the point I remove from 0.01, and 1 0 comes from when I remove the point in between 6.8 from 6.8. Okay, so only 10 will be there. So it will be 10 to 10 cancel out. Okay, so we will find out some value. We will find out some value of R2 also. Okay. So similar to that, we will find out whatever the value of R2 we find out, we just use the value of the remaining. I just remove this one. You can see with in different manner. If you want to see, then see like this. We know the frequency formula is 1.4 volt divided by R1 plus 2 R2 into C. Okay, R1 plus 2 R2 into C. The value of R1 and R2 should be in the range of 1 kilo ohm to 1 mega ohm. Okay. If you use the same kind of value and want to see the square wave at the output, or a LED is connected, then how can you find out that value? Now see there, which kind of circuitry you should use. So I remove this one, timing part, and we will see how we can find out that kind of circuit. Let's suppose I just want to blink an LED. Blinking of LED means on off. It means 100% there is a square wave. That's why on off continuously. So now how to design that? So let's suppose my R1 and R2 I choose of similar value. 2 and 6 number pin 1 mega. Okay, 1 mega. I can also design this circuitry in laboratory as R1 is equal to 1 mega ohm. Both are equal, and R2 is also 1. Capacitor C1 as 0.1 or 0.01 microfarad. Okay, 6 number pin and 2 number pin are shorted and connect with the capacitor. The capacitor should be of value 1 microfarad. Then to see the output, I have to connect LED. So instead of directly taking the output on CRO, if I connect LED over there, if I connect a LED over there via a resistor R, so that it will not be burned out due to excess of current. So the resistor I choose as 1 kilo ohm, and then one LED anode is connected, and cathode of that LED is connected with the ground. Then I will continuously notice this thing that it will continuously blink. So that is a designing of a stable multi-vibratory laboratory. Okay. So now we also want to find out. We also want to see the stable multi-vibrator on using 555 instead of 555 timer. Let I want to see the square wave or blinking of the LEDs with transistorized structure. Then what are those value of transistor, the resistors, the capacitor, whatever we I use for cross coupling. So see that circuit. Now, whenever we will do this practical on breadboard, we should choose to 1 mega ohm resistance, 1 microfarad capacitor, 1.01 microfarad capacitor, and then connect with a resistance. And when the LED will be connected, it will be blink or continuously blinking, and it will generate the square. Okay. Now the transistorized structure. So I remove this diagram. Amit, send me a snapshot right now with this MS Pen file. So I will go for the transistorized structure. If you send, then type in message box. Okay. Amit. Yes, I find it. Now see the second one, transistorized structure. So I remove this diagram right now. Now I remove this diagram right now and show you the. With the help of the transistor, it can be used. Let's suppose I have 2 NPN transistor with common emitter configuration. So both the emitter, because of common emitter configuration, both the emitter terminal will be grounded. So we will also design and see the square wave at the output using this stable multi-vibrator on breadboard. When we will choose a perfect value, what are those perfect values we just want to design right now. So the two transistors whenever connected via cross coupling, because a multi-vibrator is a circuit which consists of amplification device like these two transistors, two amplification device with cross coupling via resistor or capacitor. So here for the stable multi-vibrator, the cross coupling will be happen with the help of two capacitors. The base of one transistor is connected with the collector of another transistor via a capacitor. Similarly, the first transistor base, a collector is connected with the another transistor base via a capacitor. Okay. Yes. Then the VCC will be connected with the help of these resistors. We will connect this one with VCC. No external trigger pulse is required in this kind of multivibrator, and output will be taken out from the collector terminal of both the transistors. Collector terminal of both the transistors. In between the collector and the ground, we will take out the output first and output second. The output first, and this is V output second. So we have to design the same kind of circuitry in laboratory. So when we will see on breadboard, we should connect the same. Okay. So what transistor we should use? So any transistor, any NPN transistor like BC547, BC107, you can purchase from market and just see on breadboard, because there are three terminal. One is emitter, one is base, and one is collector. So this one is the emitter terminal. So these transistors we should use as BC107 transistors. BC107, or if you have any other NPN transistor, you can use that transistor, no problem. Okay. You should. The cross coupling capacitor should be of 0.1 microfarad. Here for this designing, the capacitor should be of 0.1 microfarad. Yes. So 0.1 microfarad. This is also 0.1. As I have already been told, those capacitors on which 104 is written. So this is microfarad. So two capacitor of 0.1 microfarad we should use for that cross coupling, and the resistors which are connected with the collectors are the 1 kilo ohm and 10 kilo ohm respectively. These resistors are 1 kilo ohm, and these related resistors are 10 kilo ohm. So we should use two 10 kilo ohm resistor, two 1 kilo ohm resistor, two 0.1 microfarad capacitor, and BC107 transistor to connected all of them with this according to this circuit diagram, and then we will check on CRO that the V01 and V02 are completely two square. Apart from that, if you wish to connect two LEDs, then you can connect LEDs with a current limiting resistor of 360 ohm, 720 ohm, 470 ohm, any one, and connect that circuit. You will see continuously blinking, so that it will show you two continuous square. Okay. So now connect this one with the VCC, and the VCC should be of in between 10 to 15 volts. So here we use 12 VCC. Okay. So this is the second case of designing of a transistor. Designing of a transistor using this transistorized structure. Okay. One more kind of circuit with the transistorized circuit we can design, like this C1 and C2 should be choose instead of 0.1 microfarad. You can, if you use the electrolytic capacitor instead of 104, that is ceramic disc capacitor, instead of that non-electrolytic capacitor, if you use any electrolytic capacitor, then choose any electrolytic capacitor like 100 microfarad. If I choose, then this right hand side, I just copy and paste this diagram with non-electrolytic capacitor. I design this. If I design like this with the electrolytic capacitor, then what are the necessary changes we should do? Like the output will be taken from the collector of those transistors. Okay. Capacitor value, if I choose as electrolytic, I just first of all remove all those values, all the values which we choose previously. Electrolytic capacitor means those capacitor on which plus or minus is written. Okay, on which plus or minus is. Let's suppose we want to blink the LEDs with the stable multivibrator using transistorized structure. So we can use this diagram. which I am going to discuss right now. With this blue color, I am showing you the necessary changes because we want to discuss about because we want to design a circuitry which can blink the LEDs. That's why a switching transistor is most comfortable. BC107, BC548, 558, these transistors are also compatible, but instead of them, we can use a switching transistor like 2 and 2222. We can use that is a perfect switching transistor. 2 and 222. 2 and two, these are also NPN transistor. Two transistor we should use. Okay. Now the capacitor, if I choose electrolytic, means on those capacitor on which plus and minus is there, then remember at the collector side both the positive terminals of those capacitors should be connected. Positive terminal of those capacitors should be connected with the collector terminal. Now this capacitor, let's suppose of 100 microfarad. 100 micro. These are 100 micro. Emitter is connected with the ground. Okay. Now the capacitors which are used, the resistors which are used, the R1 and R2, those resistors connected via the capacitor are of 10 kilo ohm similarly, but the resistance value of 1 kilo ohm should be decreases. Now let's suppose these are 510 510 instead of kilo. For a perfect value, so these are of 510 ohm. This last capacitor also of fiber is also fiber 0. Middle two registers are of 10 k each, similar to the previous case. Because we wish to see the LED is blinking. Because we wish to see the LED is blinking. That's why. Now, the power supply, because I decrease the resistance 510. That's why if I use 1 kilo ohm, then 12 volt or 9 to 12 volt is okay. If I use the resistor value as 510, then this value should be from 6 volt. No problem. Now, instead of this taking the output directly, if I wish to see the LED blinking, then two LEDs are connected at the collector terminal. Now they are connected via resistor. Okay, so here you can connect the LEDs via resistor, in which the cathode is connected to the ground. Okay, here also resistor and the LED. This is connected to the ground. These are LEDs. So I follow this illumination sign of arrow also. Okay, so these are now these resistance value 310 470. Okay, so you will see the continuously blinking. Okay, this is also 470. Right. So these three circuitry which I taught you right now using 555 timer IC circuit, uh, and we will see the square wave or blinking of the LED using transistor diagram, transistorized structure, and we will see the square wave at the on CRO. Or if we wish to see the LED blinking continuously, fastly blinking, so switching transistor is used, that is 2 and 2 then circuit is quite changed according to that value, and you will see a perfect square wave or LED blinking at the output. So that is a perfect stable multivibrator design using 555 timer IC circuit. So Rakesh Jain from Gyanware University wants to say thanks for watching the video. Now try that circuit diagrams and those values, connect them on breadboard, and you will see the perfect result. So thank you for watching the video. Thank you. Thank you.